Bismillahirrahmanirrahim. Welcome back to the @TPK Math for All YouTube channel. Unit number 4, lecture number 4, exercise 4.2. In previous lecture, we were solved question number 1 and question number 2. But now today in this lecture, we want to solve question number 3 and question number 4, which is something like find the number of terms in the arithmetic progression 6, 9, 12 up to 78. Here in this question, we have given arithmetic progression 6, 9, 12, 78. We want to find numbers of terms in the given arithmetic progression. Given that 6, 9, 12 up to 78. Here in this question, A1 is equal to 6, D is equal to 9 minus 6 is equal to 3, and AN is equal to 78. Using formula or general term of an arithmetic sequence, AN is equal to A1 plus N minus 1 into D. So put the value of N, which is equal to 78, A1 which is equal to 6, D which is equal to 3 for finding total numbers of terms in the given arithmetic sequence. Here N is equal to 78, A1 is equal to 6 plus N minus 1 into D is equal to 3. 78. Shift this 6 on left hand side. 78 minus 6, which is equal to 3 multiplied by n, 3n, and 3 multiplied by minus 1, minus 3. 78 minus 6, 72. Shift this minus 3 to the left hand side to get plus 3, which is equal to 3n. 72 plus 3, 75 is equal to 3n. So divide both sides by 3. Divide both sides by 3. 3 cancel. 3 25 are 75. N is equal to 25. So total number of terms in the given arithmetic sequence, N is equal to 25. Now let's come to the question number 4, which is the n term of an arithmetic sequence is given by N is equal to 2n plus 7. Show that it is in arithmetic progression. Also find its 7th term. We have given arithmetic sequence which is something like N is equal to 2n plus 7. We have to show that it is in AP, mean that arithmetic progression. Also find its 7th term. Solution. Given that the n term of an arithmetic sequence n, which is equal to 2n plus 7, we show that it is in arithmetic progression. Also we have to find 7 term. We have to find 7 term of the given arithmetic sequence. N is equal to 2n plus 7 is the n term of the given arithmetic sequence. If we put n is equal to 1 here, A1 is equal to 2 multiplied by 1 plus 7, which is equal to 2 multiplied by 1 plus 7, which is equal to 9. Similarly, if we put n is equal to 2, A2 is equal to 2 multiplied by 2 plus 7, which is equal to 11. If we put n is equal to 3, A3 is equal to 2 multiplied by 3 plus 7, which is equal to 13. Hence, the given arithmetic sequence is like 9, 11, 13, and then 15, and then 17, up to so on. So we have to show that the given arithmetic sequence is in arithmetic sequence. If we subtract second term from first term, 11 minus 9, which is equal to 2, 13 minus 11, which is equal to 2, 15 minus 13, which is equal to 2. Means that between every two terms here, the difference is self. So the given arithmetic sequence is in arithmetic progression or arithmetic sequence. Now we have to find the seventh term of the given arithmetic sequence. We know that n is equal to a1 plus n minus 1 into d. So a7 is equal to a1 is equal to 9 plus n is equal to 7 minus 1 into d is equal to 2. If we subtract 11 minus 9, which is equal to 2. A7 is equal to 9 plus 7 minus 1, 6. 6 multiplied by 2, 12. A7 is equal to 9 plus 12, which is equal to 21. So the seventh term of the given arithmetic sequence is equal to 21. Thanks.